Hi there. In this video, we will be talking about measures of central tendency. When we talk about measures of central tendency, we're discussing numbers or measures that represent a set of data. The measures give a general idea of what the data looks like. There are three main measures that we're going to be talking about. We have the mean, the median, and the mode. All right, let's start our discussion with a set of data points. So I say 5, 6, 6, 7, 8, 10, and 28. Let's say these are our data points, okay? The first measure we're going to talk about is the mean. What does the mean look like here? Okay, now when we talk about mean, we're talking about an average of the data. Basically, we're saying if all the data points were the same, what would they look like? Okay. And the way that we calculate this is we sum up all the data and we divide that sum by the number of data points. All right. So in this example, this is what the mean would look like, or the average. The mean would be 5 plus 6. So we're summing up all the data points. So 5, right? Plus 6 plus 6 plus 7 plus 8 plus 10 plus 28. And we're dividing by the number of data points. So let's figure out how many data points do we have? 1, 2, 3, 4, 5, 6, 7. 7 data points. So divide that sum by 7. All right, on top we have 5 plus 6, that's 11, plus 6, 17, plus 7, 24, plus 8, 32, plus 10, 42, and then 70. So we have 70 over 7, and so our mean or our average is 10. All right, so what we're saying is all this data sums up to 70. If each of the data points were the same, if they were all the same, they would each be 10. But they're not. Some are bigger than 10, some are smaller than 10, and there's even one that's exactly 10. But on average, it would have been 10. That's what that means. 10 is a representative of the data. Okay, let's go to the next measure. Let's talk about the median. So again, our data points are 5, 6, 6, 7, 8, 10, and 28. And now we're talking about the median. All right. Now our median is our middle number. Okay, so that's basically what it means. It means which number is in the middle of your data. Okay, so if you take this, for instance, the way that we will do that is to arrange them in ascending order. Okay, so from least to greatest. Then figure out which number is in the middle. So let's take this one. If we were trying to figure out which one was in the middle, we'd pair them up on the ends until we got to the middle. So this is definitely not the middle. This pairs up with that. This pairs up with that. And what's left? 7. Our middle number or a median is 7. Now, you may have noticed this only works because we have an odd number of data points, right? We're going to have one left over because we have 7 of them. And so they pair up and then you're left with 1. What if you have an even number? So let's say, what if we had an even number of data points where we had 2 and 4 and 6 and 8? In this case, what would be the median? All right, what would be the middle number? So this is how you'd find the middle number. You'd still pair them up from the ends, but now you have 2 numbers in the middle. What you do is you'd find the mean or the average of those 2 numbers. So remember, mean is just add up the numbers and divide by the total number of numbers, which is 4 and 6, so 2. In this case, our median is going to be 5. 5 is in the middle of 4 and 6, right? It's the average of those 2. So basically, take the 2 middle numbers, add them, divide by 2. You're going to get the median. Perfect. All right. If you only do this when you have an even number of numbers. If you have an odd number, it's the easiest. Just pick the middle number. Okay. Our next measure is going to be.
Okay, I just wanted to make a correction here. When I was finding the median here, I had 4 plus 6 over 2 is equal to 10. It should have been over 2. So it's 4 plus 6 over 2 is equal to 10 over 2, and the answer is 5. The 5 shouldn't have been in the denominator. So the median is 5 in this example. So this is the median, and it's equal to 5, and this is the example that we were looking at right here. All right.
Our mode. All right, so our data again is 5, 6, 6, 7, 8, 10, and 28. And our mode, this is the easiest measure, it's most occurring, okay? So it's the one that you see the most, the one that appears the most. So in this case, do you have any guess as to what the mode is? All right, if you thought 6, you are correct. 6 appears twice. Everything else appears one time, so there's one mode and it's 6. Now imagine if there was another number that appeared twice. Then you'd have 2 modes. You could have 3 modes, right? You could have more than one mode. As long as they appear the most, and if it's the same number, in this case twice, then they would all be the mode if they appear twice. Okay. All right, so far good. Okay, there's another thing that we want to talk about. Okay, so as I was saying, sometimes you can have more than one mode. All right, let's look at some data points here. So let's look at this. Maybe we surveyed a group of friends and we asked them what their favorite fruit was. And these were the responses that we got. Mango, pineapple, apple, grapes, mango, mango, oranges, and so on. Now our question here is, how many modes do we have? Well, let's see. An easy way to kind of figure this out is to kind of sample them and see. So mango, we have 1, 2, 3, so 3 of them. And pineapple, we have 1, 2, and 3 again. And we have apples as well. And how many do we have? 1, 2, 3, 3 apples. Okay. What about grapes? All right, I only see one instance of grapes, so that's 1. All right, so we know that's not the mode. What about oranges? I see 1 here and another one here, 2 of them. And then kiwi, I see 2 instances of kiwi. So that's here and here, and then 1 peach. All right, so now I know my data. Now I can talk about what's the mode. It looks like we have a 3-way tie, right? We have pineapple, mango, and apple. Each of them has stated 3 times, okay? So we have 3 modes here. And those 3 are our modes, okay? They're the most occurring, even though, and they occur at the same, they each occur 3 times each, all right? Okay, let's try this one. What's the mode here? Now, just looking at this, I see 0.3 occurs twice, all right? And it's good to write it so it's organized and you don't miss anything. 0.2 occurs only once. 0.1 occurs once. This says 0.7. It should be 0.7, so then put that there. But 0.7 occurs once as well. Okay, so that's not. So it's getting clear, okay? It's becoming clear that 0.9 is the mode because 0.8 occurs once as well. So that's just once. And so 0.9 is the winner here. This is our mode. And let me check that. Yeah, that looks right. Okay. So we only have one mode here. So in some cases you have one. Some cases you can have no mode. For instance, if you have 7, 8, 9, and 10, right? In this case, there's no mode. 0, no mode. They're all occurring at the same, every one is occurring once. Okay. And this makes sense, right? If, for instance, in this example, 7, 8, 9, 10, everybody occurs once. All the numbers occur one time. So we're going to say there's really no measure of central tendency here. They all occur once. Okay? All right. So let's go to another term that's important for us to know.
All right, so I want to include another correction here. Um, I found that zero point 0.3 occurred twice. It was here, and then the second one was right here. And then zero point 0.9 also occurred twice, both in the middle around here. So there are actually two modes here because they both occur at the same number of times and they're both the highest, right? 2 is the highest out of all the rest. So we actually have two modes here instead of one. All right.
Okay, now there's something that we can measure. It's not part of our measures of central tendency, mean, median, and mode, the main ones, but this is also something that gives us an idea of the data, and that is our range. Okay, and the range is very simple. It just tells us the difference between the maximum and minimum values. So with the data set that we started with, it was 5s, 2 6s, 7, 8, 10, and 28. In this case, our range is just, we're going to figure out what our maximum value is, and that's 28. That's the biggest number. What's our minimum value? That's 5. And our range is just going to be the difference. We're just going to subtract them. 28 minus 5 is 23. So this kind of tells us how far apart our data points are. It goes from 5 all the way to 28. So the range is 23. All right. Okay, another important measurement to consider is something called an outlier. So an outlier occurs when you have all your data that are kind of close to each other, and then you have one that's pretty far off. Okay, so let me go back to our example. So we had 5, 6, 6, 7, 8, 10, and 28. Now, do you notice anything? Well, most of our data points from 5 to 10, they're all within a range of 5, right? They go from 5 to 10. They're not that far apart, but 28 is way off, okay? So in this case, 28 is an outlier, okay? It lies outside the normal or regular range of the data set. All right, so an outlier can be bigger than all the numbers, but it can also be smaller. For instance, in this set, if I had a very small number like 0.003, that would also be an outlier, right? It would be pretty far away from 5, 6, 7, and the rest. Okay, so in this case, 28 is our outlier. And it, knowing our outlier can actually help us to figure out which measure of central tendency is the best to use. And so we're going to talk about that. All right, so talking about outliers, before we figure out which measure of central tendency is best, one question is, how does the outlier affect the mean? Or how does it affect the data? Okay, so let's go back to our data again. And we're going to figure out how does this outlier, 28, affect the mean. So what was the mean when we calculated it? Remember, we got a mean of 7 because we got 70 over 7. Oh, actually, a mean of 10. Sorry, a mean of 10. Now, imagine if we get rid of our outlier. And now let's find the new mean. So our new mean is going to be 5 plus 6. Remember, add them all up. Plus 8 plus 10 and divide by the number of data points. In this case, there are now 1, 2, 3, 4, 5, 6 data points. Okay, so what does that give us? This gives us 42, if you add them up, 5 plus 6 plus 6 plus 7 plus 8 plus 10, over 6, and that's 7. So our new mean is 7. Okay, so this might not seem very significant, but in a way it is. We went from a mean, a representative of 10, to a representative of 7. So those are different. We're saying now that on average, all the data points are 7, whereas before we were saying that they were 10. Now, imagine if your outlier was even bigger. What if you had an outlier of like 56 or something? Then your mean would get bigger and bigger. But look, your mean, in this case, 10 is bigger than most of the data points here, right? 10 is bigger than most of them. But look at 7. 7 is bigger than 3 data points, but it's still smaller than 3. So it's kind of tending towards being in the middle of the numbers, okay? So 7 is a more accurate picture of the mean than 10, right? Because 10 wasn't very representative. It was bigger than most of the other numbers. Okay, so our outlier can skew the mean. There's this word here, skew, or skew our data, right? It can make it inaccurate, where it's adding some noise, some extra stuff to our data that doesn't really tell us what the central data looks like, right? So we don't really like outliers that much. Now, if we have outliers, though, there's something that we must ask ourselves. Which measure of central tendency should we use? So let's look at that. Which measure describes the data best? That's our next topic. All right. If you have non-numerical data, for instance, you ask a group of family members, what's your favorite protein for dinner, right? Somebody says beef, another says lamb, the next person says chicken, the next person says beef, the next says lamb, another one says lamb. Now, you have all these data points, but if you say what's the median of this, doesn't really make sense, right? Median is middle number. What about the mean? The mean on average, again, we're talking about numbers. So this mean and median would not be the best way to describe this data. But what could be? The mode. Remember, mode is which one appears the most. So in this case, we have lamb, lamb, lamb. It appears 3 times, whereas the others do not. So the mode is lamb. So we could say most of the family members, they tend towards lamb, right? They like lamb. Lamb is a good representative of this family. Okay, so non-numerical data, go with your mode. What if you have numerical data? That means you have numbers, but you have an outlier. You have a big number. So let's look at this. Let's say you ask a group of students in a class what their weekly allowance is, right? So you have somebody saying $20, another says 23, 25, 30, 75, and 28. In this case, you have an outlier. Remember we said when you have an outlier and you figure out the mean, it kind of distorts the mean, okay? It makes it bigger or in some cases smaller than it's supposed to be. So it's not a good representative. Okay, so in this case, we would not want to use the mean. What about the mode? All of them appear once. So mode is not really telling us much, right? There's no mode here. So that doesn't work either. The median, though, would be a good way to kind of represent this data. When you have data that has an outlier, you might want to tend towards your median because the middle number here, so these are arranged, they're not quite arranged in ascending order. Let's do that. 23, 25, 28, 30, and 75. All right, what's in the middle? Let's see. So that's that. So it's these two. These two are in the middle. So our median here would be, remember the average of that. So add them up, divide by 2. 25 plus 28 divided by 2, which is 53 divided by 2. I believe that is 25 plus 1.5. So 26.5, it looks like. That would be our median. That's a better representative of the data. Think about it. 26.5 is in the middle here, right? It's bigger than 3 of the numbers, but still smaller than 3 of the numbers. So it's a pretty good measure of this data. Pretty good representative. Okay, what about this one? Our last one, data without an outlier. So in this case, they're all around the same thing. Distance walked, we have 1 mile, 1.2 miles, 1.4, 0.8, 1.1, 0.9. They're all around the same thing. None of the distance walked is like too out there, right? Nothing is too far and nothing is like 0.0000 miles, right? Or 0.0001 miles. So in that case, there's not really much of an outlier. In this case, we're going to say go with the mean. Average is going to give us a good idea of what the data looks like. All right. Okay, so I hope this lesson was helpful, and I hope that you're able to answer all the questions that you come across. All right, until next time.